about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is this. Check this out. I worked on this over the weekend, as promised. And we have a waveform display that keeps things in sync. They don't wiggle out of synchrony. It's not perfectly smooth. The scrolling is not perfect smooth. You can see that it jumps around a couple times. I guess some frames are dropped, perhaps. Well, the frame rate seems to be consistent, so it is not perfect, but it's good enough, and it's on par with all the waveform displays that we saw, except for the isotope one. But that one is written in C++, so I think that we are reaching the limit of what JSFX can do. So I will show you how this works. And we are going to continue this guy because it is bare bones at this point. The features that we have here on the screen are pretty much the only features I have implemented on this incarnation of the waveform display. Yeah, let's get down to the code. First thing to note is that on Friday, on my last session, I tried this idea of multi-channel circular buffers. The point of multi-channel circular buffers being that you would be able to store the waveforms in sync. So when you advance a pointer in the circular buffer, it would advance the pointers for all the waveform displays at once. And when I was working on this over the weekend, I was hitting the wall. It seems like that design is not ideal. For instance, over here when we're computing the maximum and minimum for one line. By the way, what I was calling before a slice, I'm calling a line now. In case you have been following along, I'm calling each one of the pixels on the each one of the columns, I guess, the pixels on the x-axis, I'm calling them lines. Anyway, when we are receiving samples and we are computing one of these lines or slices or columns, however you want to call them, we have to store the current maximum and minimum as well as the number of samples that we have already collected in this line. And this is so that we can eventually reach the number of samples that makes up one line. So let's say that we have one line here is 1,000 samples. But we need this temporary information so that when we get to this number, we eventually push into the circular buffers. The problem is, if we have multi-channel waveforms, then these are not simple values. They are arrays in and of themselves. One maximum per channel, right? One minimum per channel. One samples in line per channel. Of course, it's possible to do that. Just allocate some arrays and use them. But it gets annoying. The code gets really weird. It just gets too annoying. So I am not using the thing that we implemented on Friday. In fact, I reverted back to simple circular buffers. I can quickly show what the code looks like. Here we are. It's the code that we wrote together on the stream, so there is no surprises. Here is just to point out that, see, we are not receiving the number of channels in any of these. And in fact, we have returned to the previous implementation, which means we no longer have that advance function. When you're pushing a sample or value, it's already advancing the right index, which is a better interface anyway, because remember that on Friday I ran into a bug because of this new interface. I forgot to call advance. Anyway, so coming back to the waveforms, that interface was awkward, so I am just using singular values in the circular buffers and independent circular buffers for maximum and minimum, as well as independent circular buffers for different waveforms. You can see that over here I have the left and right channels, which of course in my case it's a microphone that is mono, so they're both the same, but they are in the code being implemented by looking at the left and right samples. And they're independent circular buffers, and the way that they're kept in sync, guess what? It's just by not doing anything. In fact, it may be the case that they go out of sync probably by 1 pixel at most from time to time, but it's no big deal. It's not as bad as it was on Friday or before Friday. And I guess one of the reasons why this is happening, why we are getting synchronization without having to do much work, is that we are, as you are going to see, using the simplest thing that can work. The interface is so simple, the code that implements this is so simple, and it sort of follow the footsteps of the oscilloscope by Cocos. Super simple mode of operation. Just look at the samples, loop over them, and draw them on the screen with lines. So no more bleeding, no more of that stuff. In fact, the code is a lot simpler now. So anyway, we have the minimum, the maximum, and the number of samples in the current line that we are collecting. We are doing this, what I'm calling decimation, of going from 40,000 samples a second into just a couple lines. We are doing that in the audio thread. In these circular buffers, they are big enough that they hold. And by the way, these are the circular. So we are doing this work in the audio thread, and we are pushing into the circular buffers in the audio thread as well. But these circular buffers are big enough that first, I don't need to copy the information from here into somewhere else. So I simplified the design there as well. And they are also bigger than what you see on the screen. The reason being that there will be that race condition where the audio thread is going to start writing into the circular buffer in the middle of the user interface thread reading from the circular buffer. But that's not going to be an issue for us because the circular buffer is a bit bigger. So it has a little space, a little scratch space to deal with the race condition. So the solution for this race condition is to just allocate a bigger circular buffer and not worry about it. In pretty much same way that the solution for synchronizing the waveforms was to just not worry about it, do it the simple way. Simplicity wins the day, I guess. So the initialization is nothing fancy, but I guess there is one thing that I want to change about this. And we are going to right now as we review the code. And that is, I am hard coding a lot of things actually, but I'm hard coding the size of the circular buffers. And here I'm being pessimistic and allocating 10,000 elements for each. So it means that we could have an 8K display with this thing full screen, and we would have enough. I guess we would have enough space to show all that. But that is a lot of space that we don't necessarily need, certainly not for this case. So I guess I'm going to receive as argument the maximum length, and you may be wondering, well, or maximum width, actually. Perhaps I'll call it width maximum. You may be wondering why it's the maximum of which width. We haven't talked about a width yet. Well, when you're drawing, you have to pass me the width of the component. So here you will have to pass the maximum for me to allocate the circular buffer. And we do need that scratch space. So let's say that we'll have 50 pixels, which is probably enough. 50 pixels to avoid that race condition, to avoid that glitch. And in case you don't remember what I'm talking about, it is this glitch that happens on this implementation here. I'll say something and pay attention to this point here. See how that's crazy? Yeah, it is actually wrapping back here to the waveform that is passing over here at the bottom and replaying that on the top. That's a little glitch that stems from this issue I mentioned, the race condition, where the audio thread is writing, the UI thread is reading, and they are stepping on each other. So with 50 pixels more than your maximum width, then that should be fine. And in many cases, you know your width is fixed. It's not based on the size of the screen or anything. So you probably can just pass here a number and then pass there that same number. But in case you do want to make it resizable, then you have to be pessimistic and allocate as many lines as possible. And naturally here, where I'm using this, I have a component that is 300 by 200. So I guess I will pass 300 by 2 or 300. Doesn't matter what the height will be. The height, you can just scale things, but the width you have to be specific about. So in this case, it's 300. So I'm allocating 300 pixels across, and 300 is a much smaller number than 10,000. But 10,000 is a good maximum for big displays. Let's see if this still works. All right, and it seems to work, and we don't see that glitch happening. Yeah, no glitches. It is fine. Moving on, how do you push a sample? This is what's happening on the audio thread right there. And you can imagine that this is going to be the place where we do the bulk of the work, actually. We do the decimation here. And that means we are going to take this sample and we are going to compute the line, effectively. We are going to take samples and we are going to compute each one of these lines, the vertical lines, across that make up the waveform. We have a bunch of local variables here. They're mostly just stuff from the data structure. These are the places. This is where this code should be familiar at this point. But what this does is just take the maximum between what we currently have and the sample that came in, which means in the end, we will have here the maximum sample that we saw in that period. So if 48,000 samples are going to make up 300 pixels, then it means that we'll have 160 samples per pixel, and then this will hold the maximum pixel between those 160. Similarly for the minimum. It's going to be the minimal pixel, or the minimal sample for those 160 in the period. And then we have a simple counter that is going to loop around, and it's important that this samples in line thing is using the circular counter, because the number of samples per line may be a fraction. So this takes care of that. And we also introduced here an auxiliary function that checks if a circular counter has wrapped around. Then we push the lines and reset the lines. We push the lines into the circular buffers. Then to draw, there is one trick. There is one trick here that I want to point out. The trick is, I need to know in the audio thread how many samples there are in one line, this variable. How many samples am I supposed to store per line? That number, the number of samples per line, depends on the width of the display and depends on the duration that you want to show. So if you want to show 5 seconds in 300 pixels, that is going to determine how many samples you're supposed to collect on each line. How many samples a line represents effectively. So there is something that is related to the drawing, namely the width and the duration, that influence this part. So the way that I'm doing this is a bit of a hack, but it is super nice from the user's perspective. And that is, I start with conservative values where the number of samples per line is infinity. So you will keep collecting and never producing a line. But at the end of this waveform draw, you will see, it's actually so small that it's right here. You will see that it is computing the number of samples per line based on the arguments that were given and updating that. So there is a way for the audio thread to communicate with the user interface thread to pass along the lines, right? The audio thread is going to receive samples and produce these lines. But there is also a way for the user interface thread to communicate back with the audio thread, and it communicates the number of samples per line that has computed based on the arguments that were passed for drawing. And in most cases, you will not be changing these numbers. So you will be computing the samples per line over and over and over, and it's going to be the same number. But it's okay, it's just a bunch of multiplications and divisions. And we are on the user interface thread where we have much more room to play. If we were doing spurious computations on the audio thread, we would have to rethink it, maybe, perhaps not, but it would be more troublesome. But just a couple of multiplications and divisions here on the user interface thread, it's completely fine, it seems. And this is the entirety of the implementation of the waveform drawing, which is remarkably simple so far. Of course, it's not doing everything we wanted to do, but it's a remarkably simple starting point. So what do we do here? We loop over from left to right into the circular buffer, and we draw a bunch of lines. So each line is going to be vertical. You can see that the X positions in the start and end points are the same. And then we compute the top and the bottom based on the line maximum and minimum. We saw this formula plenty of times before, so I'll not walk you through everything that is going on here, but in essence, that's it. We just draw lines. We are not using rectangles. We are not erasing stuff. We are not drawing to off-screen canvases. We are not bleeding. We are not doing a lot of things that we were before. And it seems to work well. So that's that. That's how this is working. Now, of course, this needs to support plenty of features that we had before. Rectification and square roots and perhaps a non-scrolling mode, but I don't know. We may have a non-scrolling mode or we may not. We'll see. So yeah, the code that we had before is here commented out. So let's go over what we had and remove stuff that we no longer care about. What do I return on this push, sample push? Yeah, I think I would like to return the sample like we were before. Yeah, now it's time for us to add some more of these parameters. Maybe not all of them, but let's check which ones we care about. Currently, we have just the basics. Let's see what else we want. X and Y width and height could be on the same line like they were here. Then whether you want to square root, rectify, scroll, I will start with square root. That one is kind of cute. rectified peaks I think would be nice. Yeah, these three features I think would be nice, but perhaps we'll leave them for later. And then, another thing I did not implement was a contour. So perhaps we will do that. Yeah, let's do the square root though, because it's so easy. We will need to say that perhaps we want a square root in one and not on the other. I think I will do false and true. Whatever, doesn't really matter. And then over here, we'll have to take the set square roots. And I forget how we did it. I think we did it by hand, but I think it would be nice to extract this into an auxiliary function. Yeah, this computation I think would be nice to extract into an auxiliary function. And it's one of those little mathematical helpers. Let's see where we can drop it. Numerical functions, yeah, that seems like the right place. Right, I'll drop it here where we do square root preserving sign. I'll leave myself a to-do to test this, because I'm not going to write the test for this now. All right. Preserving sign, I guess I will be just saying square root with sign. And there you go. We can now use that here. But of course, we only want to do that if the person is asking for the square root. That should do. Let's see. Yeah, so the one on the bottom looks a lot thicker because it's taking the square root of numbers between -1 and 1. So it emphasizes the numbers. It's not just a simple scaling. It is a scaling, I guess, but it's a scaling that is nonlinear. Right. Another thing that we have to do, I will just drop it here in the comments. We have to take care of clipping. We may get to that in a moment. Yeah, sounding good. Since we are here, taking care of clipping needs to be done right in this location, so perhaps it's time to do that. So let's add a tone generator and I will show you what I mean. The issue is that given enough room, see, when we are at 0 dB here, this is the maximum. This is the edge of the drawing canvas. And you can see that it's going beyond the edge. It should not. So let's take care of that. Oh, and another cute way of showing this is with some sort of gain. And now I turn this on, and Oh, it's not enough. So perhaps let's do plus 30. And now, yeah, it's definitely going overboard and going on top of the other one. Yeah. All right, let's do this. So yes, here is a fine way. Here is a fine place to do this. And do we have something to clip? We do. Between -1 and 1. Okay, and now it is not going below. As you can see, it's clipping here. Let's do the tone generator version. So it should go as far as here, and it doesn't go beyond. Perfect. We took care of clipping. I'm thinking that perhaps we can do one that we didn't yet, because it can be boring for me to just essentially port the implementations of all the features we had here. It can be boring to do that. So instead, let's do one that I have not done yet. And that is to do a vertical waveform. I think it makes sense here on the track control panel to do the thing that this guy does, which is to show the waveform vertically, going from top to bottom, instead of horizontally going from right to left. So let's implement this one, because we are in the bare bones stage here, so it should be relatively straightforward. There's probably one change in terminology, because width can be misleading. If you're thinking about the waveform vertically, then width will be misleading. So I guess I will rename the width maximum, which should only appear in these 3 locations. Yes, I will rename this to something that may be even more appropriate, which is lines length maximum. Yeah. And then the X, Y, width, and height still makes sense. But we'll have to revisit this. I learned during the session this weekend, the session that I didn't stream, I learned that in JSFX the list of arguments can end with an optional comma. And I like that, so I'm doing that now. Right, so do I want to have it as a vertical thing? Perhaps yes. Both examples. This is just a throwaway example, but yeah, vertical. So let's do that one. So how is that going to affect things? Well, let's go line by line and figure it out. So instead of line X, now it's the line, the main axis, I guess the main and secondary axis. There is a terminology related to this when it comes to Flexbox. Main axis and cross axis, I guess. Yeah, main axis and cross axis. I think I will follow that terminology. All right, and now with this terminology, there is nothing too tight about left and right and top and bottom. So the terminology now works this way. And so far I have only renamed stuff, so everything should continue to work. And I added an argument that we are not really using so far, but it should still work. Let's see if it really does. Okay, everything still looking the same. Now we'll commit what we have. And let's add a bunch of ifs, because essentially that's what this is. It's going to be a bunch of ifs. So to begin with, if I am doing the vertical thing, I'm going to compute these guys differently. Because we are going from top to bottom when drawing this. Yeah, we are going from left to right. Hang on, I'll have to bring in the other one because I'm not sure I have this straight in my head. So right is going to become top, because the thing is going from top to bottom, and this one is going from right to left. So right is going to become top, which means that if we are going from left to right when drawing, we need to go to from bottom up, which means that here we'll be doing y plus height, and when we change this, we need to be doing -1. Like this, because we are going from bottom up. And offset will be the height. Oh, I think we forgot to rename some stuff over there. Let's go over the local variables. Line X is now line main. And then these are the cross axis, and this is now the maximum and the minimum. All of this remains the same because it's just the treatment of the samples themselves. But this will change, because it's based on the height, so it better change. Hi, what does the question mark mean? Hello, M9. The question mark means if. It means square root is going to either be true or false, okay? Square root is going to be either true or false. So in JSFX, true is represented with any number except 0, while false is represented with a 0. So if you know C, same story. 0 means false, any other number means true. So it's going to check this. Square root is either going to be true or false. It's either going to be 0 or non-zero. And if it is true, then it's going to run this block of code. I'll show you another example over here. So vertical, is it true? If so, run this block of code. Otherwise, that's what the column means. Run this block of code. So this is essentially an if then else. If you were to write this in some other languages that you may know about, you would do this instead. Okay, so this is how you would write it in C, C++, Java, JavaScript, and many others. And this is how you write it in JSFX. And the cool thing about this syntax, which also exists in C, except that in C you cannot put a block here. I guess you can. Yeah, so the cool advantage of using this piece of syntax is that it also returns a value. So it's not just running a block of code, but it's also returning a value. So you can use this to do this kind of thing here as well. Yeah, it's not a shortcut because in JSFX, the if syntax, the if keyword, it does not exist. It's not a shortcut. It's just a way that you can represent conditionals. It's just a way to conditionally run a block of code in JSFX. But yeah, the long form does not exist in JSFX. And strictly speaking, if in languages like C is a statement, it doesn't return a value, while this returns a value. So I guess it's more evident here. This returns a -1 or 1. Okay, so far so good. We also need to address this part where if I am doing vertical, then I actually want to do the height of the window, the height of the component. And then where else do we need to change stuff? Over here, this. Yeah, if we get these 3 lines right, then we have this. I can see that the logic I want is similar to this one there. So I guess what I am going to do is extract this into a variable. And I'll have this variable perhaps, yeah. I'll call this the main, I guess, and it will be over here at the top. All right, so what is the main axis? If I am vertical, well, I want to think about the other case first. If I'm not vertical, if I'm horizontal, the main is the width and the cross is the height, and vice versa. So height, width. And now the cool thing is that this offset is no longer special. We can just put it there and it will be minus the main. But the line main is still special. Because of this, we need to go from bottom up. That's all right. Then we are not looping over the width, we are looping over the main. And then over here, I'm divided by the main. Just to check, when I'm talking about the vertical one, the main is the height, and the width is the main of the other case. So yeah, this is gonna work. And then here, Yeah, I think I want a couple more variables. I have the main and the cross, but I guess I'm going to rename them. I will call this the main length and the cross length, because the main and the cross are going to be the x and y. I'm not using this variable yet. I may not use it. I don't know. We'll see. Okay, and let's also define the main and the cross. If I am drawing horizontally as I was before, the main is x and the cross is y, and vice versa. Cute. So this reads very well, and here I'll have it this way. All right, everything in here makes sense. So this is not y, this is cross, and this is not height over 2, this is, I guess, the cross length over 2, and all the rest makes sense. Yeah, all right, so now we need to check if I am drawing vertically. Then I will need to switch some things around here. If I'm drawing vertically, I want the x, which is the main, to remain fixed, so I will, or the y, sorry, I said x. The y I want to stay fixed, so I'll do something like this. And I think that this will do. Perhaps I will want to swap these two. Yeah, I think I want to swap these two so it draws from left to right. I don't know, I'll have to think about this one for a moment. I'm not sure. I have to first think if it even matters, because it may not. But what I'm thinking about is that some signals are asymmetrical. They are bigger on one side than the other. This is not the case on this one, but yeah, it's definitely the case on this one. Sometimes it is bigger on the top and smaller on the bottom. I guess there is a spike here on the bottom and not on the top, for instance. So I want to make sure that the spike is on the right side of the curve when the thing is vertical. All right, let's do a quick review to see if we forgot something. Okay, everything looks good to me. We'll give it a spin. It seems to be working. It looks a bit weird because they're touching in a weird way, but that's just because of the places where I asked the thing to be drawn. But yeah, it is going from top to bottom. And you know what I'm gonna do? I'm gonna do the following. It's not they're going to be drawn in one horizontal, one vertical, but they're going to be drawn one on top of the other so we can compare the left-right thing that I was talking about. So when I have something that is asymmetrical here, well, one is also taking the square root. No, one is just larger, so it may be difficult to compare. You know what's gonna make this easier? Let's do a DC offset. Why do I have two DC offsets, one capitalized, one not? Okay. Okay, so now I can move this signal around easily. And the question becomes, am I moving to the right location? Does this make sense? So if the right is going to become the top, it means that the top is going to become the left, because you're sort of taking this waveform and then rotating it around. So it means that when I go to the top, I want to see this one going to the left. And it is. Great. Similarly, the bottom is going to become the right. Awesome. We did it. I don't think it really matters the order in which I draw this. If I did it the other way around, I think it would work just the same, but whatever, it works. So we did something new today. And I now want to compare our version to this one. And I would say that it's an improvement. I think that ours is looking good. It is not displaying the same time. This is longer. It's taking 5 seconds for the audio to go through, and this is much faster. But still, I think that ours is, yeah, it stands to the competition. And there is one advantage of ours. It is properly taking the maximum and minimum of the samples, which means that if I click, then here we for sure will see the click. Here we may not. See that spike? See, it's almost gone here, but it's there. So ours is more correct. Great. M9 says, how are you going to use this? For example, making it show multiple channels overlay on top of different colors. Yeah, I have plenty of uses for this component in mind. I'll give you some examples. And thanks for asking, by the way. I am planning on doing a version of this, which is meant to be used embedded on the mixer control panel. So it looks like this. You can see the waveform going through, which is sort of nice. That's a simple use case. I'm also planning on using this on a compressor, because I think that the main goal of my work here with JS Effects is to help you see what the effects are doing. So there are compressors that show what they are doing to the waveform, but they are few and far between. None of them do exactly things the way that I think they should be done, so I'm creating my own. And in terms of the algorithms in the compressor, it's probably going to be something straightforward, following the textbook examples of compressors to begin with anyway, but it will show what's happening. So I think perhaps we would have a grayed out waveform of the audio coming in and a lighter, more prominent waveform of the audio coming out, and you would see compression as it's happening, which is super cool. Then I also think of using this component on a similar, it also has to do with dynamics, but it's not a compressor. It's called an auto mixer. I don't know if you have watched my channel recently or if you're new here, but the auto mixer is an effect that I have that works in a situation where you have multiple microphones in a room, and it adjusts the gain of the different microphones so that, imagine a round table interview kind of situation. All the microphones are open all the time, and it will change the gain, the relative gains of the microphones depending on who's speaking. And I think that having a waveform display for that will be excellent as well. So I'm planning on adding that to my implementation of the auto mixer. Yeah, and just in general, I wanted to know how to make a waveform that would work well. So I guess it was also for enlightenment. Yeah. And yeah, showing multiple channels should be relatively straightforward. And this one is only mono or stereo, but we can have ours, and we have already in previous incarnations of this, have it support however many channels you want. So there's that too. And we, of course, do have more tricks up our sleeve. We can save computation when the thing is not displaying. Plenty of small tricks like that. Okay, we have 5 minutes before I have to wrap up. So I will implement one more thing, which is to select the color, because it is so straightforward. This is setting the color. I would just receive the color as an argument and set it. So we can even get here and where do I want to have the colors? Probably after everything else here. So I will take the color of the fill, and do I want some sort of transparency? I think so. All right, let's do this. I don't need to do it here. I can do it before the loop. At least for now I can. So I will set the color to be the fill color and the alpha to be the fill opacity. And then when using this, we need to provide a color like red 500 and an opacity completely opaque, or perhaps not. Let's do 50% opacity, just because I want to make sure that it is going to display correctly, that the opacity is going to display correctly. We had problems before when we were using different techniques to draw where opacity was not free, but I think in this case it will be free. Yes, it's a good idea. Will you have a line showing the gain level, etc.? Yes, and I was so diligent. I worked on this waveform display for months now because I wanted this to be able to scale well. And I think that with the strategy we came up with is it scales super well. It is going to let us have like dozens of this scrolling components. So we can have two waveforms, as I mentioned, compression inputs and outputs. So they're going to be overlaid on top of one another in a way that you effectively have to draw two waveforms. We can have that, but we can also have a line for the gain reduction and more. But yeah, the essence is I wanted to make this scrolling widget work as well as possible so that we would be able to have a bunch of lines and waveform displays and all of those. Okay, if I did everything correctly, we should be able to load this. And yeah, it is red, but it's definitely not 100% opaque. And Oh, I guess this component also needs to set opacity. So let's go real quick to the frames per second component, and where we set the color, let's set the alpha to you can see that this is slightly faint, and now it is not. Okay, opacity works, and I think I rather have opacity of 100%. And this is what it looks like in red. Cool. We implemented the colors, and it only took us 3 minutes. So are there other low-hanging fruits that we can do in 1 minute? Yeah, we can clean this up. The previous code, we can clean it up. So rectification is a feature that we may want to have. Scrolling, or perhaps not scrolling, right? Because now it is scrolling. So not scrolling. We already implemented this. A contour, a cursor, opacity. I think opacity will apply to each one in this case. Then all these local variables I don't need. All of these I don't need. This I don't need either. This is already in place. All of this can go. This is something that I may want to do. This is so that if you bypass the effect, it stops on its tracks. I think I would want for it to clear, to reset. Then this is the logic we implemented today for the most part. Rectified peaks. There isn't a lot to see here, but perhaps this line is worth having. And then everything else here we have implemented already. Or maybe not. Is there something interesting about the scrolling situation? No. All of these we can get rid of. We have taken care of this. Oh, but there is one interesting thing here. The erasing. Yeah, I'll keep this line around for reference. This is all junk. Okay, so these are essentially notes. They fit on one screen now, and they're essentially notes of things that we want to implement and sketches of how we have implemented them in the past. So we can refer to the implementations and formulas when we get to this, which is probably going to be tomorrow. So thank you, M9, and everyone else who is watching this either now or in the future. Tomorrow I will be back and we will continue doing this. We will add more of these features. So perhaps rectification or the option of not scrolling the waveform display. And when I say not scrolling, I mean doing something like this. So this one is not scrolling, it's just going from left to right and then wrapping back. So doing something like that. Drawing the contours, perhaps drawing the cursor if we decide to do the non-scrolling version. and much more tomorrow here on the stream. Oh, final question. You taught yourself this? For the most part, I read a bunch of JS effects that come with Reaper. I read a bunch of forum posts, a couple books, and I'm banging my head against the wall for months now over this. So about more than half a year at this point. So in my first JS effects, I have written about 1 or 2 years ago. So yeah, that's how I learned all this. And yeah, so thank you, M9. Thank you, everyone else. I see you tomorrow. Have a good one. Bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.